Okay, so let me start with 2 and 3 and ask questions if you guys are stuck. And all the answers are displayed below. So if you ever get stuck, try sometimes reverse engineering or looking at the notes. That could help. And when I say looking at the notes, obviously you gotta be filling out notes too, right? You're not just, watching the videos, but you're writing stuff down as you're doing this. So right here, you have 6 squared plus 10 squared equals x squared, right? Very simple. So 36 plus 100 equals x squared. 136 equals x squared. Very good. Therefore, x is root 136. Not that hard, right? Very easy. However, if you look at the answer key, it's going to express a little differently. It's going to say 2 root 34. How do you get 2 root 34 from that? And what if I put this as a multiple choice question where I don't have root 136 as one of the options? So what you could do is look at 136 and create a prime factor tree, meaning find factors of 136 and pull them out, and factors that are prime, meaning having exactly 2 factors, one in itself. So 2 is a prime number, and 136 divided by 2 is 68. And you can break down 68 like this, and you break down 34 like this. So if you think about it, it's root 2 times 2 times 2 times 17. It's the same thing. 2 times 2 times 2 times 17 is 136. Now the first 2's can actually be combined like this. So you have 4 times 34. And root 4 and root 34 can be broken apart like this also. You have that luxury of doing that with radicals, that you can break them apart like this. The reason I can break them apart like that, a radical is like an exponent. For example, if I have 2 squared times 3 squared is the same thing as 6 squared, because you can combine the 2 and 3 as long as these exponents are the same. And since square roots are like exponents and you're square rooting 4 and 34, you can put them back together or break them apart like I just did. And root 4, of course, knows 2. So that's how you get 2 root 34 is the answer for number 2. Now, a workaround, if you're not comfortable simplifying radicals, on an exam, what you could do is if you get root 136, you could get the decimal answer by plugging it in your calculator. I think it's like 11 point something, root 136. Yeah, 11.66. And then what you could do is when you look at the choices, you could plug in each choice into your calculator to see what those decimal equivalents would be. So for example, if C2 root 34 is one of the choices, you plug it in your calculator, you look at 11.66 as well. That's a match. Then you know you have the answer. So you can always do a workaround using the calculator. That's just using a good test strategy. So that's just something to think about. And then finally for number 3, for this set, and then we'll move on to another set, you have x squared plus 12 squared equals root 369 squared. I'm going to do this a little more quickly because I know if you've got this, you're a little bored right now. You get 369 because you squared a radical, it just goes away. You square a radical, sorry. So x squared is going to be 225. The square of that is actually 15. So that's going to be okay. So hopefully those two are pretty straightforward. Just Pythagorean theorem, not that hard. And yeah, video, I promise I will not delete it. I will upload to YouTube as soon as we get done. And we are going to be finished by 11:30 today because I got to go pick up my daughter from camp and bring her back for lunch and pick my son from camp after that while there's a babysitter here, so kind of running around today. But I will I'll make sure it's downloading when I'm heading out to pick up my daughter. Number 4, we did 4, sorry, 5 and 6. So you're asked to classify, and someone's I know someone had emailed me like they're a little confused about classification. So there are 3 categories, or sorry, 3 classifications. There's acute, right, and obtuse. Acute, right, and obtuse. Acute would look kind of like this, where every angle is less than 90. Obtuse would look like this, where one angle is more than 90, and then clearly the other 2 are less than 90. And right is just you have one angle that's 90 degrees. So this is greater than 90 degrees right here, and every angle here is less than 90 degrees for acute. So how do you go about classifying?
what you do is you take each side and you square it. So for number 5, I'm going to do 3 squared, 3 squared, and 3 root 2 squared. That's 9, 9, and 18. Easy peasy, right? 9, 9, 18. And by the way, 3 root 2, that's 3 squared times root 2 squared, right? So 9 times 2, 18. So, yeah. Now what you do after that is you take the 2 smaller sides, which of course are 3 and 3, and you take the biggest side, which of course is 3 root 2, and you see how a squared plus b squared compares to c squared. If a squared plus b squared equals c squared, then you know you have a right triangle. Well, let's see here. Remember, a and b are 3 and 3, so that's going to be 9 plus 9. We square each of those individually. And c squared, remember, c is 3 root 2, so
that squares 18. It's pretty clear that 9 plus 9 equals 18. Therefore, this is a right triangle because it satisfies the Pythagorean theorem. Now, what if I had something else? What if the second side was 4? Then, of course, that's 16, right? And 4 is less than 3 root 2, by the way. 3 root 2 is like 4.4, I think. Or actually, I should know that. I think it's like 4.2 something. But anyway, if you do that, now you have 9 plus 16 compared to 18. Clearly, 9 plus 16 is bigger than 18. So when that happens, that's going to be an acute triangle, because what's going to happen is they have 3, 4, and 4 root 2. So this angle here actually bends in. That doesn't bend to the left, bends to the right. Because what's happening is that you have this side that's now becoming a little bigger, right? So that's what's happening for that one. Or what if I had my biggest side is like, say, 5. What if I had 3, 3, 5? So now I'm doing 5 squared, which I know is 25. So I have 9 plus 9 and 25. Of course, those are not equal. Now 9 plus 9 is less than 25. When that happens, that's going to be obtuse. And the reason that's obtuse is that we had 3 and 3 here originally. And then we made this side a little bigger. As the result of making the side bigger causes this angle to increase, right? Because if you were to widen that angle, it would make the side opposite angle bigger, right? And so now that becomes bigger than 90 when it was 90 previously. So hopefully that makes some sense as to how we go about this. So let's try it one more time. Let's square the 13, let's square the 18. And if you're not sure what 3 root 55 is, get one of these guys, or get one of these guys. And actually, if you even Google 3 root 55, it'll probably tell you that what the decimal is. But if I did 3 root 55, and by the way, I didn't have this when I was your guys' age. We didn't have Google, or we had calculators, but not as nice as they are now. But 22.25, right? That's 3 root 55. So that's clearly the biggest side. So I'm going to square each of these. I get 169. I get 324. And I get 9 times 55, which is 495. Now you compare. 169 plus 324 and 495. Well, 169 plus 324 is going to be 493. Ooh, that is so close. But it's not equal to 495. In fact, it's less than 495. So this is going to be an obtuse triangle when that happens. Okay, so hopefully that makes some sense. So generally speaking, a squared plus b squared equals c squared. That's right. A squared plus b squared is less than c squared. That's obtuse. A squared plus b squared is greater than c squared. That's acute. So hopefully we're A-okay with that. Okay. All right. So let's keep moving. For number 8, these are a little strange. A question in the chat. Question 4, sure. Yeah, question 4 we did in class, but I remember I, obviously deleted the video. So you just do the same thing, 15 squared, 20 squared. Use a calculator, you get 225 and 400. And then another 15. Oh, I think I did 25 yesterday. Okay, I think I might have done 25. I think I saw the 25. So that might be why you're confused, Vivian. So you have two sides are 15. I didn't see that. I thought this was a 25. So that's going to be 225 plus 225. Those are the two shorter sides. And of course, you got 400. Well, it's pretty clear that 225 plus 225 is 450, and that is greater than 400. That's acute. So 4 is acute, 5 is right, 6 is obtuse. So my apologies if I confused you guys with 4. Maybe you thought it was, yeah, you probably didn't. So how did Mr. Yu get obtuse? Or sorry, how did Mr. Yu get a right triangle? Because I thought that was a 25. That's that last number there that says 15. My apologies. Hopefully that clears up any confusion. I'll leave this up while I work out the next problem. So for these problems, these are a little strange. Whenever you see something like this here, this kind of scenario, we have a right triangle, then you make make two more right triangles inside that right triangle. These two sides here, the product of those two equals this side squared. You can just memorize that, of course. And the answer is going to be 6, by the way. But we want to understand, we don't want to memorize. And by the way, this is a concept that if I haven't taught geometry in a while, I forget. But I still can figure it out because I break down the triangles. I'm using some strategy. I'm using some of my problem solving skills. That doesn't go away, right? I mean, those are skills that stay with you for a lifetime. And you want to develop that. And I'm here to help you develop that. So let's talk about how you can look at number 8 a little differently, as opposed to just saying, well, I know 4 times 9 is 36. And there's a formula that says that when you have the scenario, you multiply 4 and 9, set equal to the altitude, which is x squared. X squared equals 4 times 9. X squared is 36. X is 6.
My iPad's gonna overheat.
Oh no. I wasn't saying oh no about that. I smudged the mouth.
Sorry, you might have unmuted yourself, Ellie. So no worries. Okay, there we go. Awesome. All right. So how can you break this down? Number 8. What if I had labeled these A, B, C, and this right here I'll call D. So you can make 2 of the right triangles. I can make one right triangle looks like this, where D is a right angle, A is up here, and B is right there. Actually, let me do it the other way around. Let me put B up top. So kind of rotate it like this, where AD is 4, and this side's X. Okay, let me actually do it in colors for that. Then you have another right triangle, BDC, where I'll put C up top. And D is my right angle again. And I'll put B right here. So this side will be X. And this side will be 9. Because CD is 9. Now, why am I orienting it this way? The reason why I'm doing this orientation, what if this angle here were like 20 degrees? Then this would have to be 70, right? Because you got 90 right there for angle BDC. Well, if you look at the big triangle, ABC, if angle C is 20, this is 70 as well. If you trace the big triangle, ABC, angle C is 20, angle A has to be 70 because angle B is 90. And then therefore, now you look at ADB, the smaller right triangle, that has to be 20 degrees. So now I have similar triangles. This would be 20 degrees. This would be 20 degrees because we see that in the diagram. The one right below, and that's 70, that's 70. Now, do I know exactly those are 20 and 70? No, I just made those up. But the point of making those up is that if I'm hypothetical about one of the angles, I can then figure out what the other angles would potentially be. And I would see that these small triangles that form the bigger right triangle are similar. So now I know I can use proportions. X here corresponds to 9 here. And 4 here corresponds to X here. And I can cross multiply and solve. X times X is X squared. 4 times 9 is 36. And you get 6. Yes, it's more roundabout, but this now enables me to understand this more deeply, because now I'm relying on a concept that I've known for 30 plus years since I took this in high school in 1992. I think I was a sophomore when is that right? Was I sophomore? Yeah, I was a sophomore in 1992. Anyway, long time ago, 30 years ago. So when I took geometry as a sophomore. So yeah, that's just something that kind of sticks with you, because you see, yeah, that these are proportional. I mean, these are somewhat triangles because, of course, my angles are the same, so the sides have to be proportional. But I had to establish that similarity by using some hypotheticals, and using some problem-solving skills, like saying, okay, what if I hypothetically assume these angles are this, and then reorient the triangles? That's part of the problem-solving skills. Then I could feel like I could move forward with the problem. So that's number 8. Hopefully that helps a little bit. I would watch this again if you're still a little confused about it. Watch again, maybe try number 7. Number 7 is very similar. You could check the answer. And actually, you got 9 and 10 also very similar problems. For number, actually, now I know what's going on. I could say, kind of redraw this really quickly. That's 12 and X, and that's 16 and 12. So then it's 12 over 16 equals X over 12. Cross multiply, 144 equals 16X. You should get 9. So you can just reorient that. So this triangle here, I rotated 90 degrees clockwise to get it to line up with this triangle right there. This one's a little tricky, but you can kind of do something similar. What you'd have to do is you have to look at the big triangle, ABC. That's actually, am I right in doing that? No, I'm wrong in doing that. Let's look at this triangle. My bad. ADB. Okay, that's 20, and that's X. And then this triangle. That's B, D, and C. And I think I'm supposed to, shoot, I'm kind of messing this up pretty hard. Give me a sec here. ADB. I'm a little confused about this one, because this one's actually not working as nicely as I'd anticipated. Give me a sec here, guys. Oh, I'm a total idiot. I can solve for this side. I know the side's 25. Okay, I was initially right by looking at the big triangle. Yeah, that's 25. I should know that. Yeah, because obviously that's 15 and 25. 15 and 20, sorry, you can use Pythagorean theorem to solve for this. If you use Pythagorean theorem, just trust me, that will be 25. It also follows a 3-4-5 ratio as well. Okay, so there we go with that one. Okay, then if I look at this triangle right here, well, that's X and 20. Now I can actually do a proper comparison. 15 over X equals 25 over 20. There we go. 300 equals 25X, X is 12. Boom. Got it. Okay, sorry, I struggled there a little bit. I didn't realize I should use the Pythagorean theorem. Just double check the answer key, make sure I'm not wrong. Yeah, make sure I'm right and 12. There we go. So that's what we do for those kind of problems. We try to reorient them as a problem-solving strategy, and then do proportions after that. Here, remember we talked about the special right triangles. Now you could use trig, by the way. If you want to start using trig already, you could. Like I could say sine 30 degrees equals x over 14. I could totally do that because x is opposite 30 degrees and 14 is hypotenuse. And remember SOHCAHTOA. Remember, sine of an angle is the opposite side. Let me color code that. Over the hypotenuse. So see the S, the O, and the H. So if I take the sine of an angle, then I set it equal to the opposite side divided by the hypotenuse. The opposite side is clearly x, the hypotenuse is clearly 14. Then you can use a calculator. Sine 30 degrees will be 1/2 if you use a calculator. Equals x over 14. X will have to be 7 to make that work. So you could use trig to do these problems. I won't fault you for that. That's totally fine. But you don't have to use trig if you know the ratios. So 30, 60, 90 triangle follows this ratio here. That is 30 degrees. That is 60 degrees. This is x, this is 2x, and that's x root 3. So the side opposite 30 we call x, and the hypotenuse is called 2x. So the hypotenuse is always double the shortest or shorter leg. So that has to be 7. And by the way, this would be 7 root 3 because it's x root 3. So I could apply that for number 13. This is 30 degrees because 60 degrees is right here, obviously. So if that's 8 root 3, then hypotenuse is double. So this is going to be 16 root 3. So the answer is 16 root 3 for number 13. Because hypotenuse is double the leg opposite 30 degrees. The leg opposite 30 degrees, if I'm calling it x, then the hypotenuse is double that. And the other leg is root 3 times the shorter leg. So you have 16 root 3 for number 13, and you have 7 for number 12. So the answer is 7 for number 12, and 16 root 3 for number 13. Hopefully we are okay with that. Okay. All right, let's keep moving. 15, then 17, then 19, 21. Okay, so 4 more problems before we finish this homework review, then we'll start 8.1. How tall is the tree if the angle is 55 degrees? Okay, so if we switch the angle to 55 degrees, so that's 55 degrees, and that's slope 4. I'm assuming that's what's happening, and that's h. You gotta use tangents. So you always have to determine. So if you guys want like I don't want to say a cookbook recipe, but I mean I you know sometimes have to follow a recipe that I kind of look at over and over again. Determine if we need sine, cos, or tan based on whether we have op, adjacent, or hypotenuse. We change that to red. Okay, determine if we need that. Okay. Then, number 2, the proper trig function, sine, cos, or tan. Okay, that's the second step. And the third step solve for x using your algebra skills. So 4 is the base, you have the height, you have 55 degrees. So what do I got here? I want to solve for h, that's clearly opposite 55 degrees. I have 4, clearly that's adjacent to 55 degrees. So which one am I going to use? The one that has an O and an A. Tangent. So boom. Got step 1 done. Okay. Step 1 done. Use tangent. Now set it up. So you can say tangent of 55 degrees equals opposite, which of course is h, and the adjacent, which is 4. Boom, number 2, done. Then solve for x or h, whatever, using your skills. Obviously, I see a 4 on the bottom, so multiply by 4, and use a calculator. Tangent 55 degrees, but use a calculator. You get 1.43, multiply to 4, you get 5.7. So it's 5.7 feet. That's all you gotta do. Again, now you got the video. I'm gonna promise I'm gonna upload it. You can watch it. That's what you do. Let's try this again. I'll leave this up here. I'll leave the instructions up here because maybe that you guys might find it helpful. Let me delete that. Let me erase this here. Again, hopefully you see how that equation works. We're okay with that. Okay, so let's look at number 17. Let's do it again. So you have 25 degrees, right? Obviously, x is opposite 25 degrees. Obviously, 20 is adjacent. Which of these I'm going to use? The SO, the KA, or the TOA? Clearly, I'm going to use the TOA, right? Because it's O and the A. So you say tangent 25 degrees equals x over 20. And you just solve it, right? Multiply both sides by 20 and work it out on the calculator, and you'll get the answer. Okay, question in the chat. 14, sure. 14, the diagram's already given to you, so you do the same exact thing. Tangent 75 degrees equals x over 4, because that's opposite, and that's adjacent. Multiply both sides by 4, those cancel, and whatever that is, that's your answer. That's that. Shoot, did I erase? There we go. Okay. Let's try another one. Let's look at number 19. This one actually just asks to find the sine of x. So opposite is right here, hypotenuse is right there. We're looking at x. So sine x is just 55 over 73. Not that hard. Or cos of x. Cos of x is going to be adjacent over hypotenuse. So adjacent is obviously at 48. So 48 over 73. That's all for that one. And then finally for 21, you're asked to solve for the missing angles. So you're still going to do the same thing. You're still going to determine which trig function you need. And then you're still going to set up an equation and then solve. So for 21, what do we got here? So let's say I want to solve for x, right? Clearly 18 is opposite x. Clearly 25 is hypotenuse. So you have to use O and H. That's going to be sine. So you say sine of that angle, which is angle x, equals 18 over 25. And then in order to solve, this is a little tricky, but you have to do the inverse trig to get rid of the sine on the left side. And then you put inverse sine on the right side, and 18 over 25 inside that function, and use a calculator to work it out. And make sure you're in degree mode. You can also do this in Desmos. Inverse sine of 18 over 25, you should get 46.05 degrees. Or say 46.1 degrees. Therefore, angle Z will be 90 minus that number, which is 43.9 degrees. Okay, that's all. So again, those are the 3 steps. Let me take a screenshot if you like. Determine if we need sine, cosine, or tangent based upon whether we have O, A, or H. We're gonna have a combination of 2 of those 3 things of the opposite adjacent or hypotenuse. And then set up the equation once you know which one you're using, and then solve. And the solving, just depends where X is. If it's on the right side and X is a numerator, then multiply both sides by the denominator. If X is on the denominator on the right side, multiply both sides by X and divide by whatever X is being multiplied by on the left side. If X is an angle, or the unknown that you're trying to solve for is an angle, then you have to do the inverse trick. So you see, and now you have all these scenarios here. And again, like what if you had something like this here, going back up, just totally being hypothetical. What if you have sine 40 degrees equals 10 over X? Remember, we multiply both sides by X first, and divide by sine 40. And you got your answer. Okay. Well, that was a pretty thorough review. Hope you're feeling a little better about it. I think I'll give you guys some extra practice. I'll send some homework that will involve more trig practice. So now it's 10:10, and I do have to leave by 11:30 to pick up my daughter, so in about an hour, 20 minutes. So do the math, that's 80 minutes. We'll see if we can do 8.1, 8.2, and 8.3 in about 20 to 25 minutes each. That should be perfect. So we're just gonna keep the train moving here. So let me open up 8.1. Ooh, there are some slides. Are these good slides? How long are these slides? 6? Yeah. Sure, why not? And then let me look at the problems that are assigned here. I think what I'll do is I'll probably do the slides. What's day 2 about? A little different. That one's not too bad. What's day 3 about? Okay, so I think I could manage this. So let me go through the slides because I think that is important. Let me kind of do a little teaching here. So we're going to talk about polygons in this section. A polygon is just, the shapes we've been working on. Like if you have 3 sides, it's a triangle. If you have 4 sides, it's a quadrilateral, and so forth. We've talked about pentagons and hexagons. Octagon, for those who've watched MMA, the ring there. I used to watch UFC when I was much younger. My wife can't stand all the violent stuff that goes on in those fights. I would argue boxing is more violent, more dangerous, but anyway. But she don't think she likes boxing either. But octagon, is that the shape of the ring? There's 8 sides. And of course they have like the fence. We don't really see nonagons and decagons in real life. A stop sign is an octagon, by the way. If you drive, you see a stop sign, so make sure you stop. It's that's an octagon. Pentagon, that's where our defense department for our country is located. It was attacked during 9/11 about 21 years ago. Is that right? 21, yeah, 21 years ago. So that's the shape of a pentagon. Quad means 4. Tri means 3, like a tricycle. Hexagon, where we kind of see that. Maybe if you like to build stuff, like a hex nut, like it has like 6 sides on it. I don't know. Don't really see heptagons or dodecagons. But things that will apply to all these shapes is this right here. This is the sum of all interior angles. So if I had a hexagon, for example, n's the number of sides, by the way. If I want to know what all these angles add up to, so let me say I labels A, B, C, D, E, F, right? A, B, C, D, E, F. I want to know all 6 of those angles add up to. I could use that formula. You simply plug in 6 for n. Do 6 minus 2 times 180. You get 4 times 180. Oops. Ah, goodness. Yeah, 4 times 180, which is going to be 720. So all the angles in hexagon add up to 720 degrees. And actually, every time you increase the side by 1, you increase the some of the angles by 180. A triangle I know adds up to 180. A quadrilateral will be 360, like a square or a rectangle. A pentagon is 540. A hexagon is 720. A heptagon is 900. An octagon is 1080. So I'm just adding 180 over and over again. If you did this one, that'd be but did I lose count? Hope I didn't. 1160, I think, is the next one. No, 1260. Let's double check. Yeah, 1260 is a nonagon. And a decagon's 1440. So anyway. So you can see some examples there, right? Not that hard. Measure interior angles for polygons. The blue circle represents angle DEA. So it's an interior angle. DF is exterior. So interior is inside, exterior is outside. You guys should know that. The exterior of your car, the interior of your car, the interior of your house, the exterior of your house. You guys should know that. Not that hard. Here, if you have a 4-sided figure, so a quadrilateral, and you want to find this angle right here, you have to realize it always adds to 360 because you do have 4 sides. So 2 times 180 is 360. So all these add to 360. So 3 that you do know, add them up, take the difference from 360, and you get 72. That should be a very, very straightforward calculation. Very, very straightforward. Not that hard. Not much really to annotate here. It's pretty self-explanatory. Side 4. If it's regular, we talk about regular. Regular means all sides the same. All sides equal, and all angles are equal. So if you have a pentagon, all 5 of these would be the same. So first you figure out what all the angles add up to, which is 540. And you divide by 5 because you got 5 angles, right? Because it's a pentagon. So each angle will be 108 degrees if it's regular. So you have this as a resource. And I did share the hard copies of this. You can download from Schoology. So what this means is that if that's 108, then the extra angle is 72 because that forms a linear pair. So all the extra angles add to 72. This would be 72, this would be 72, this would be 72, and this would be 72. Kind of looks like a ninja star. So that's 72, that's 72, that's 72, and that's 72. If you're to add it all up or multiply by 5, because you got 5 of them, you get 360 degrees. By the way, for any shape, any polygon you got, the extra angles will always add up to 360. Regardless of how many shapes you got. If you have more sides, then the extra angles just get smaller. That's all. So and I'm not sure if that's brought up. It is brought up in the last slide. But here's yet another example. What if you're told that all the angles add up to a certain number? You want to figure out how many sides you got. Then use this formula right here, where this represents the sum of all angles. We just saw this formula just a couple minutes ago. It's right here, n minus 2 times 180, right? N minus 2 times 180. And then just solve, right? You could, it's just done step by step. Distribute the 180, add the 360, divide by 180, so you get 8 sides. So if you're told that a polygon has all of its angles add up to 1080 degrees, how many sides does that polygon have? Use this formula n minus 2 times 180 to work that out for you. And you'll have a chance to practice that on the worksheets. And then finally, measuring interior angles for polygons. Yeah, as I said, they're all at the 360, all the exterior angles, right? So what if you're told that each exterior angle is 120? Then what you do is you'd say, well, if all of them add up to 360 and each one's 120,
then clearly there has to be 3 sides. And we'll let n be the number of sides. So there's another form you can kind of consider. 360 over n equals each exterior angle measure. And this is for regular polygons, by the way, if it's regular. Because all of them have the 360, and if it's regular, they're all going to be the same. And n being the number of sides, so that's what you do. So I could have done a problem like this. I could have said 360 over n equals 120, multiply both sides by n, and then divide both sides by 120. So there you go. Okay, so now we can do some practice. So the sum of the measure of the interior angles of a convex polygon is given, classified by number of sides. Here, find the value of x. And here you got something with baseball. And interestingly, actually, not all baseball stadiums have the outfields the same way. In fact, actually, some are have like different corners and stuff like that. I'm trying to remember how Oracle Park is for the Giants, but I know that's a more expansive outfield. Some are a little more compact. But for this one here, the sum of the measure of the interior angles is given, classify it. So you're going to say n minus 2 times 180 equals 1980. If you so desire, you could divide both sides by 180 right off the bat. If you do, you get n minus 2 equals 11, n equals 13. There you go. So you'll try number 2 on your own. In fact, actually, why don't you guys try number 2 right now, and put your answer on the board. Oh, sorry, on the chat. Okay, could someone please put an answer on the chat, please? Wouldn't be 11, because remember, we got 11 for 1980, so it's got to be more than 11, right? So n minus 2 times 180 equals 2340. You divide both sides by 180. Yeah, 15. I'd agree. So yeah, just be careful with your math. If you divide by 180, plus also we went 360 higher from 1980 to 2340, so we're adding 2 more sides, if that helps. But if you divide by 180, you'll get n minus 2 equals, I believe, 13. Add 2, you get 15. There we go. Hope that makes sense. For number 3, find the value of x. Clearly you have 5 sides here. So all the angles are going to add up to 540. So you're going to say 86 plus 140 plus 138 plus 59 plus x
if we work that out, you should get 117. Okay, so you should get 117 degrees for number 3. Going to try number 4 now, but clearly we have 6 angles here. You have 90 degrees in the lower left corner. You have 4 other angles that are provided, and then you have x. So clearly n is 6 here. Go ahead and put in the chat your answer for number 4. Okay. Yes, go, Sean, you have a question. Or
I
you
think I
have the
figured
answer.
it out, but on number 3, did you get the 3 from subtracting 5 minus 2?
Yep.
Okay.
100%. Yep. So yeah, for number 4, you should have just add all that up. 90 plus 121 plus 162 plus 96 plus 101 plus x equals 6 minus 2 times 180, which I know is 720 if you were to work that out. So you got to work all that out, right? Okay. So 150 degrees for number 4. And let's check out the chat. Yeah, so it's 150. Remember, everything has to add to 720 because you're doing 6 minus 2 times 180 or 4 times 180. And add all that up, 90 and 121 and 162, 196, 101 and x, and you get 150. That one. So just be careful when you're punching it all in the calculator. There's some more. Just trying to think in the interest of time. All signs for homework. I think that probably makes the most sense. Let me kind of give you a little hint for number 9 and 10, but I think you guys kind of get the idea. Actually, let me do number 7 really. All right, let me do number 6 really quick. I'll do number 6. Remember all the angles, all extra angles after 360, regardless of the number of sides. And so you work it out, and you should get Yeah, 111. There we go. So not too hard. You do likewise for 7 and 8. And number 5, you have 1, 2, 3, 4, 5, 6. You have 7 sides, and 5 of the angles are given. So you're doing 7 minus 2 times 180. I think that's going to be 900. And you add all that up, x plus 2x plus all the other junk has to equal 900. Sean, go ahead. You have a question. Go ahead, Sean.
So what does the 2x mean? Does that change anything?
No, that's just one of the angles. Actually, let me take that back. How many sides are here? Oh, wait one sec. That is weird. Oh, no wonder you're confused. I'm confused too. You know what? That might be a corner. I see where you're getting at this. So maybe it's 1, 2, 3, 4, 5, 6, 7, 8 sides, maybe. I don't know. So yeah, maybe that's just like close to 180 degrees. I don't know. So yeah, so in this case, then we have to do 8 minus 2 times 180. So that's gonna be 1080, and then 1080 equals x plus 2x plus all that other junk. Okay. Nine. You have 5 sides here. For those who don't know, that should be a right angle. That should be a right angle. That should be a right angle. Let me do that in red. In baseball, the baseball diamond. And I'm pretty sure between the first base foul line, the third base foul line, with the outfield, that should be 90 degrees. So you have to figure out what the rest there. Again, n minus 2 times 180 is the sum of all the angles, and you have 5 sides here. Here we got 6 sides, kind of a funny looking baseball field. And again, you have a right angle at home plate. Right angles. Oh, actually, you have to find the sum. I'm losing my mind. There's just 5 sides. You just do 5 minus 2 times 180. And here you do 6 minus 2 times 180. Sorry, I just lose my mind there. They're not asking for individual angle measures. So it should be pretty straightforward for 9 and 10. Okay, so definitely I'll ask you guys to finish the rest of this for homework. Not that much left to do. Let's keep moving because we still got 2 more sections to talk about. 8.2 and 8.3. So I'll do the evens and have you guys try the odds. That might save some time. So when you got a parallelogram, very important. Actually, let me do a little teaching here for you guys. So you may want to annotate these notes somewhere, or maybe on a separate piece of paper, write this down. Hold on, it's just being silly. Okay. When you've got a parallelogram, so this right here is called a parallelogram. Parallelogram, okay. I don't know if I could spell parallelogram. It's going to have two pairs of sides that are congruent, so the symbol, and parallel. So for example, those are parallel and congruent. those are parallel and congruent. So that will always be true. That will be a parallelogram. Now, is a rectangle parallelogram? Sure. Yeah. Is a square parallelogram? Sure. They're special because they have all right angles. The other thing too is that the opposite angles are congruent. So this is the same as this, and this is the same as this. That's also true. Okay, opposite angles are congruent. Okay. So that's a little teaching there. We'll get a chance to copy. Just gonna get some water from the kitchen. All right, sorry about that. Also had to make some toast for myself too, so get a little distracted when I get to the kitchen sometimes. So that's parallelogram. Okay, so now we're going to, oh, another thing too that they should realize about parallelograms is that these sides are parallel, obviously, right? These add to 180. Because after all, those are parallel lines, right? And remember, we talked about same side interior angles, right? Same side interior angles or consecutive interior angles add to 180. So it's the same thing that's happening here. If I were just extend those sides and have a transversal that goes through it, yeah, that happens. And then likewise over here, which explains why these are the same. That explains why those opposite angles are going to be the same, because of the parallel line phenomenon we have going on here with two pairs. So now let me share my screen and let's do some problems. And again, I'll do the evens and I'll have you guys try the odds in just a sec. So these have to be the same because they're opposite of each other. And 20 has to be in Z minus A because remember you have two pairs of congruent sides. The opposite sides are always congruent and parallel. And you just solve, right? Not that hard. Yeah, go ahead. Question.
Where did you get 108?
You know, I don't know. Because I made a human error. Thanks for catching my mistake. My apologies. Okay. I don't know where I got 108 equals 126. That was silly. Thank you for catching that again. And Z is 28. So not too hard, right? The other thing too, which I forgot to mention, is that the diagonals bisect each other. So for number 4, you have two diagonals. And the reason they bisect each other is, again, because you form these congruent triangles. In fact, actually, if you really want to go on the deep end, you can start using like some of those triangle congruence terms, like side angle side or stuff like that. I'm not going to do that. Well, I could do it really quickly. Those sides are going to be the same. Those angles are going to be the same. And also, these angles are the same because of their alternate interior angles. So now I know the triangles are congruent by side angle angle. I'm not going to ask you guys to know that, but I'm just trying to tell you that these are forming congruent triangles when you have the diagonals crossing each other like this. So it means that
corresponding sides are going to be the same. Like b minus 1 is going to be the same as 9. And 15 is going to be the same as 5a. So if you were to use some of your knowledge that we've discussed, you would see that like this triangle here is the same as this triangle here. So b equals 10. And then 15 equals 5a. A equals 3. So this is the same as this. And b minus 1 is the same as 9. So diagonals bisect each other and you just solve. Questions? I'll give you a chance to copy or verify. Okay. Told you I get distracted when I go to the kitchen. All right, let's keep moving. 6. I'm guessing this is y plus 4, 4y plus 4. So 5y equals 4y plus 4. Y equals 4 when you work it out. 3x equals 12. X equals 4 when you work it out. That's all. Questions on number 6?
What does x equal? I can't. Is that
4.
11?
4.
4.
Yeah, my handwriting stinks. Yeah, you just set them equal to each other. And then these here. This will be 85 because that's 85. Those are alternate interior angles. So if you had parallel lines like this, and you drew a line between them like this, and if this were 85 right here, then that's 85 right there. Same thing, alternate interior angles. That's all that's going on. Therefore, this is 45 right here. And if I have 1685, that's 145. This has to be 35. Therefore, this is 35. And that's 60, right? Remember, all the angles add up to 180 in the triangle. And what else I got? If that's 60 and that's 60, this is 120. And that's 120. Right? Because 60, 120 out to 180 and forming a linear pair. Therefore, this is 15. And that's 15. All angles out to 180. So for EJF, that's 120. For EGF, that's 85.
For HFG, that's 35. For GEF, that's 45. And EHG, that's 50. Let me replicate this one more time for you guys. So you see all this in motion again. Okay, so you knew this is 85. So that must also be 85 right here. You knew this was 45. So that must be 45 right here, because those are alternate interior angles. And plus opposite angles are equal to each other. 85 plus 45 is 130. So you have 130, 130. Then if you know that this is 60, then that is 60. Therefore, that's 120. 120. Okay. And then if that's 60 and that's 85, then that's 35. Therefore, this is 35. And if that's 120 and that's 45, then that's 15. Making that 15. So if we could see how all that unfolds. Okay, go and try 1, 3, 5, 7. Give you guys maybe a few minutes to do that. And you can put your answers up in the chat. Actually, you have the answers down below. You don't have to do that. If you have questions, please put some in the chat. So we'll start with 1 and 3. Okay. I hope we get M is 5. Not that hard. N is 12. There we go. Here you get G is 61. Here you should get H is 9. Questions? Pretty easy. Okay. We'll see 5 and 7. And then we should be able to do 8, 3 just fine. So remember, these are the same. And those are the same. Here you're going to want to draw A, B, C, D. So that's 14 and that's 20. We want the perimeter, which means you want to add up all the sides. Just give you guys a minute or two. Okay. Should be done by this point. 4M equals 16. M is 4. 9 minus n equals 2n. 9 equals 3n. N is 3. And then here, if that's 14, this is 14. If that's 20, that's 20. Just add them up. Let's get 68. So hope that's pretty straightforward, pretty easy. Nothing too challenging, hopefully. Okay, any questions on this worksheet? Okay, I think we have a little bit of time to finish up 8.1. Don't want to give you guys too much homework. So why don't you guys go ahead and work out, I did work out number 6 for you guys. Remember, always have to add the 360. So you can do likewise for 7 and 8. Then here, remember, we said x plus 2x plus all the other junk has to add up to 8 minus 2 times 180, which by will be 1080. So 3x plus all that junk. What is that junk anyway? 143 plus 139 plus 152 plus 116 plus 125 plus 140, 815. 1080 minus 815, 265. Divided by 3. Okay, kind of weird, but so be it. 88.3. So that's number 5. Go and try 7 and 8. Okay, so this one here, you're gonna have x plus 2x plus 40 plus 45 plus 77 equals 360. if you work out correctly, you should get 360 minus 40 minus 45 minus 77 divided by 3. Should get 66 for this one. And then for this one here, we got 1, 2, well, it doesn't really matter. You have x plus all the other junk has to add to 360. And what do we got here? We got 2x. What does all that junk add up to? 58 plus 39 plus 50 plus 48 plus 59, 254. If you solve for x correctly, you should get 53. Okay. So 6, 6, and 53 are the answer, 7 and 8. Sean, go ahead.
How did you get x equals 66, the part on your calculator?
I added these up and then moved it over to the other side. So 40 plus 45 plus 77, all that adds up to 162. So I moved that over to the other side, 360 minus 162. So I get 3x equals 198. And then divide by 3. That's why I got 6, 6. So remember, when you have the exterior angles, all of them add up to 360. So you set up an equation, solve for x. Yeah, go ahead.
How did you get 15 though?
15.
Yeah.
What do you mean by 15? What do you mean by 15? I understand.
You plugged in 15. Oh, is it 45? Oh, okay.
45. Sorry. There we go. Yeah, I'm just taking the angles. My handwriting sucks, but I'm just taking angles that are there and just plugging into the equation. That's all. So that should wrap up 8.1. Of course, we finished 8.2 a few minutes ago. We're going to start 8.3 in just a little bit. And again, I'm sorry for no breaks. I know we're kind of powering through, but we are done earlier. We started a little later. And then, of course, we'll do more chapter 8. And I just uploaded your homework, so I don't forget to do it, because I'm going to be pretty busy this afternoon watching my kids. But I did upload some homework. It's just going to be more review of trig. I'll show it to you before we end our session today. Okay. Let me go ahead and clear the screen. Hopefully that's okay. Actually, I'll wait another minute. You guys want one more time? Okay. So now let's move on to, oh, this one right here. This had 5 sides. So you're just doing this. This has 6 sides. So you're just doing this. Because the question is asking, find the sum of all the interior angles, and remember the formula is n minus 2 times 180, right? So, okie dokie. Hopefully we're okay with all that. All right, so now let's move on to 8.3. Just so I pace myself appropriately. Yeah, it should be pretty easy. Again, I'll do the evens and have you guys do the odds. We haven't really talked about theorems, so I'd say Y is the quadrilateral a parallelogram. That's what I'd say. Here it's because opposite angles are congruent. Here, opposite sides are congruent. That's all. And for number 3, the doorway shown in part of a building in England. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know doorway is a parallelogram. That's because the length of each side has not changed. And probably started as a rectangle. So that's just more just open-ended, kind of thinking through it. It probably started as a rectangle. I mean, obviously, if one of the sides expanded, the other one's contracted, then something else is going on there. But I'm just guessing if it's leaning, the sides all stay the same. So you still have 2 pairs of opposite sides that are congruent. You know, like this side here, let's use red. Are the same, and of course these are the same. Okay, let's keep moving. Now, if you want to make this a parallelogram, the diagonals must bisect. And also, same side interior angles add 180 degrees. So in this case, 2x plus 3 must equal x plus 7. Where here, 6x must equal 3x plus 2. Because these are also going to bisect, and these are going to bisect. Then over here, x plus 3x adds 180. And that's going to add to 180 as well. So go and work those out until you get. Okay, hopefully you get x equals 4 here. Here should be x equals 2/3. Here you should get x equals 45. And here you should get x equals 30, I think. No. 50. Okay. It's more of an extension of parallelograms. Okay, so let's keep moving. Just two more problems and we're all done. So here, you're being asked to plot the points, draw and show that it's a parallelogram. So there are a few ways you could do this. I would suggest using slope. So if you have two pairs of parallel sides, remember the two L's like that means parallel. Two pairs of parallel sides. Then you have a parallelogram, meaning that you're going to want the same slopes. So -2, -3, 4, -3, 3, 2, -3, 2. Kind of looks parallel to me. Well, they have to show it actually. They're all going to be parallel, I guess. -5, 0, 0, 4, 3, -1, -2, -4. So if I were to find the slopes, and let me label the corners, by the way. A, nope, A, B, C, D. So slope of AB is just going to be 0, because you're doing -3 minus -3 over 4 minus -2, which actually becomes 0 over 6, which is 0. And slope of DC will also be the same. Also be the same. Then, if the slope of BC, 2 minus -3 over 3 minus 4, positive, positive, get 5 over -1, or -5. And if I do it again for DA, I have 2 minus -3 over 4, or -3 minus -2. I get the same thing. Yep, -5, -5. So that will prove that this is the parallelogram because you have two pairs of sides that are parallel, because you have two pairs of sides the same slope. You can also do distance too if you want to do a distance formula. Go ahead. It's kind of up to you. Actually, you could have done this. Another way you could do it is if you have one pair of sides that are both parallel and congruent, then that would also be good enough, because then naturally the other two sides will be parallel and congruent. And we know DC, by the looks of it, has a length of 6. And AB also has a length of 6. So same slope and same length, that's also good enough too. And this last one here, we could probably take that same approach. If I find, so let's label this, that's A, B, C, D. So if I do Pythagorean theorem or distance formula, I find that the length of AB is going to be 5, and the slope will be 3/4 because you go up 3/4. And if I look at DC, because it's opposite to it, yep, I'm going up 3/4 again. And it has the same length as well. If you do Pythagorean theorem, you get the same length. Length of DC would also be 5. Sorry, that's really messy handwriting. That is awful. I could do better than that. So that could be good enough to prove that these are parallel. If you want to find the slope for 4 sides. So anyway, so that's how you could prove it. And we'll reinforce all this stuff tomorrow. And tomorrow we are on Zoom again from 9 a.m. to 1 p.m., but we'll have some breaks. Maybe we'll end a little early. Also, Thursday we're in person. I will hand back the midterms in. Test correction for the midterm will be due, I'll make them due Monday of next week. So Monday the 18th. So have some time to do that. We do have a test in person on Thursday. So we'll review for an hour, do a break, and do the test. And usually we're done before 12 o'clock on those days. What was I going to say? I'm drawing a blank right now. Oh yeah, I'll have test review materials. I'll work on them late tonight, and they'll be ready by tomorrow morning. So I'll give some details about our next test, which will be on this Thursday. Homework, yes, let's do that. Let me go and clear this. Homework will be this right here. So just click on homework. Homework number 11. And just one item. And it's going to be a worksheet on trig, giving you guys a little more practice from that. I'm sensing that some of you guys probably would want. So if I download this and just show you how it looks. So not that much different than what we did on Monday or yesterday, where like here you have an angle, you have to solve for the missing angle. You have to use the right trig function to figure it out. Or here, find the missing side and round to nearest tenth, and you have to use trig again to work that out. And then solve each triangle means find all the missing sides and angles. So if you see one side, then you got to find the other 2 sides. If you see, obviously you're going to see 2 angles because one is a right angle, then you got to find the missing angle. The missing angle is easy. They all have the 180. That's not that hard. It's more about finding the missing sides. So you use some trig. But you could use trig for one of the sides and Pythagorean theorem for the other after you find one of them using trig. So you have all the answers here. But again, you're going to be using trigonometry. And if you guys get stuck, I did put a couple of links to help. I mean, obviously, if you have our notes, you have my, well, the one video I shared, that's not my video. So finding a side and right angled triangle tells you what you need to do, tells you about SOHCAHTOA, and just works it out for you. So you have that resource there to help you, and also finding a missing angle. You have that as well. It tells you, you got to use like an inverse trig to figure it out. So hopefully you're okay with that. Just trying to think if there's anything else I need to share, but I think that pretty much covers it. I'll stop sharing. I can stick around for a few minutes if anyone has any questions, but we'll go and end our call for today. So I know we didn't do any breaks, so thank you for hanging in there. So we covered the homework from last time, the chapter 7 test review. We've done the first half of chapter 8. We'll do the second half of chapter 8 tomorrow. And we'll do some review of chapter 8 as well, and we'll talk about the test. So we're moving. We're moving. And by the way, I produced all the hard copies for the remaining units for this class, chapters 10, 11, and 12. We're skipping chapter 9. So I'm going to make copies on Thursday morning when we're in person and hand it out to you guys. So you guys have everything for the rest of the class. And yeah, we're done in about 2 weeks. We're done pretty soon. So it's going by fast. All right, so let me go and stop the recording